In previous video, I told you that before differentiating any expression, if it can be simplified, first we should simplify the expression and then differentiate it. Now, for simplification we use algebraical formulas, trigonometrical formulas, logarithm, etc. Now, today we shall study use of the logarithm for finding differentiation. We do use logarithm for differentiating whenever there is product of or division of more than two functions, or if it is the differentiation of fx raised to gx. So, either this is differentiation of more than two functions, or if it is differentiation of fx raised to gx. Now, for use of the logarithm, we use the formulas of the logarithm. Log of AB equal to log of A plus log of B. Log of A by B is equal to log of A minus log of B. Log of A raised to m log of A. Though it is very simple thing, but you always remember log of x plus y is not equal to log of x plus log of y. Now let us see how we can use logarithm for differentiating. For example, if you have to differentiate x raised to x, so let us take y equal to x raised to x. Take log of both sides. So log of y will be equal to x log of x. I have applied log of a raised to m is equal to m log of a. Always remember, if base of the logarithm is not mentioned, it should be taken as e. So, differentiate it 1 upon y dy upon dx shall be equal to x 1 upon x plus log x. X as it is, differentiation of log x. I have applied the product rule. X as it is, differentiation of log x is 1 upon x, log x as it is, differentiation of x is 1. So, dy upon dx shall be equal to y into 1 plus log x. So, this is equal to x raised to x log of ex. Whatever you like according to answer. So, he has given x raised to x log x raised to x log of ex. This is the answer. What I told you? I told you whenever there is product of the more than two functions, division of the more than two functions, or if it is of the form fx raised to gx, what you have to do? Take log of both sides and then differentiate it. This is very important question. X raised to x log of ex, x raised to x log of ex. Differentiation is x raised to x into this. Second question is of the same type. This is x raised to sin x. Take y equal to x raised to sin x x raised to sin x. Take log of both sides. Log of y will be equal to sin x log of x. You differentiate it and then get the answer. Next one is Differentiation of 1 plus x raised to 1 upon x. This is very important differentiation as far as limit is concerned. So, this is y equal to, so log of y will be equal to x log of 1 upon x. Differentiate it, this will be equal to log of 1 plus x, differentiation of x is 1 plus x as it is, differentiation of log of 1 plus x is this one. How? This is the answer. So, y will be equal to, this is log of y, so 1 upon y divided by dx shall be equal to y into this. You can tell it the answer. So, x1 plus x raised to this will be equal to this. So, answer will be sorry, I have differentiated, written the question wrong. Y equal to log of y will be equal to log of 1 plus x upon x. Now, apply the rule u upon v and then differentiate it. Next is differentiate y equal to under root of 1 minus x upon 1 plus x. Now, this question can be done in two ways. Either you put it y square equal to 1 plus y upon 1 plus y, 1 plus x upon 1 minus x, or you take log of both sides. So, log of y will be equal to half log of 1 plus x minus log of 1 minus x. Differentiate it, 1 upon y divide upon dx, 1 upon y divide upon dx, that will be equal to half differentiation of log of 1 plus x will be equal to 1 upon 1 plus x plus 1 upon 1 minus x. So, answer will be half y upon 1 minus x square, y upon 1 minus x square. You can take it like this also, y square equal to 1 plus x upon 1 minus x, but answer will be in different form. Answer will be in different form. So, next question, y equal to under root of 1 plus root x upon 1 minus root x. If you take log of both sides, log of y will be equal to half log of 1 plus root x minus log of 1 minus root x. You differentiate it and then tell it the answer. Next is same manner, y equal to 1 plus under root of 1 plus root sin x upon 1 minus root sin x. Same thing we can do. So, this will be the answer. Next is y equal to under root of 1 plus root log of x 1 minus root log of x. Same thing, log of y will be equal to half log of 1 plus root x 1 plus under root of log x minus log of 1 minus under root of log x. Differentiate it and tell you the answer. Next is, this is good question, y by 2 minus y by 2 x upon y like this. Second one is, this is good question. Now in next part, we have seen use of the logarithm for finding differentiation. Now in next part, method of substitution. In these questions, majority time sin inverse x, cos inverse x, tan inverse x like will appear. Now first thing is this, you can do the questions by substituting x equal to sin theta, cos theta, tan theta like this. While substituting this thing, what you have to keep in mind, if outside this it is sin inverse, you put value of x in such a manner that inside also sin appears. This is the first way. Usual way is this. Second thing is this, that you should remember to do the multiple choice questions. You should remember the formulas for the inverse functions. For example, I am illustrating it in both the ways. First method is this, that y equal to sin inverse 2x under root of 1 minus x square. So y equal to 2 sin inverse x. We do remember the formula sin inverse 2x under root of 1 minus x square is equal to 2 sin inverse x. This is the first method to do the question. Second method is this, if this is dy upon dx will be equal to. Better is this, that you should remember the formulas so we can differentiate the function immediately. Second way, if you don't remember the formula, then what I told you, that you put x equal to sin theta, cos theta, tan theta in such a manner that if inside the bracket this is sin inverse, outside the bracket if it is sin inverse, inside the bracket we should also get sin. So if I put x equal to sin theta, then y will be equal to sin inverse 2 sin theta cos theta. 2 sin theta cos theta. So this will be equal to sin inverse sin 2 theta. So this will be 2 theta. This will be 2 sin inverse x. Now again differentiating it, same answer will come. Here immediately we can get the answer. If you don't remember the formula, then I have given you the method for substitution. What you have to keep in mind, if outside the bracket this is sin inverse, inside the bracket it should be sin. If outside the bracket it is cos inverse, inside the bracket it should be cos. Okay? Now, next question. Let us see next question. What is telling, this question has been asked in examination. ये कहता है कि y equal to tan inverse 2x upon 1 minus x square है, and x is greater than 1. X is greater than 1. So when x is greater than 1, 1 minus x square shall be negative. 1 minus x square shall be negative. So in 3 or 4 years back, this question has been asked in second grade examination. So this is y equal to tan inverse 2x upon x 1 minus x square. So y will be equal to pi minus 2 tan inverse x. If you differentiate it, dy upon dx will be equal to minus 2 upon 1 plus x square. So, out of this, no answer is here, so it will be none. Next is, differentiate y equal to tan inverse sec x plus tan x. Tan inverse sec x plus tan x. If you simplify it, sec x plus tan x will be equal to tan pi by 4 plus x by 2. Tan inverse pi by 4 plus x by 2. So this will be equal to y equal to pi by 4 plus x by 2. Now this is very good question. So differentiation of this will be equal to half. Question number second was very important. Similarly, question number third is very important because if you do no simplification, question can be done orally. Otherwise, it shall be a lengthy question. Now, question number, let us see. Next question. Differentiate y equal to tan inverse 2 raised to x plus 1 upon 1 minus 4 raised to x. If I put this as tan inverse 2 into 2 raised to x upon 1 minus 2 raised to x का whole square. If I put 2 raised to x equal to tan theta, 2 raised to x equal to tan theta. Y will be equal to tan inverse 2 tan theta upon 1 minus tan square theta. This will be 2 tan theta upon 1 minus tan square theta will be equal to tan 2 theta. So we shall get y equal to 2 theta. Now y equal to 2 tan inverse 2 raised to x. If you differentiate it, dy upon dx will be equal to 2 into, now what will be differentiation of 2 raised to x? Tan inverse 2 raised to x upon 1 minus 4 raised to x. So answer will be 2 raised to x plus 1, 1 minus 4 raised to x, then log of 2. So this will be answer. 2 raised to 2 into 2 raised to x plus 1 आएगा. So 2 raised to x plus 1 into 2. This will be the answer. Now, next question. Differentiate y equal to tan inverse cos x plus sin x upon cos x minus sin x. I can write cos x plus sin x upon cos x minus sin x as 1 plus tan x upon 1 minus tan x and 1 plus tan x upon 1 minus tan x. This will be equal to tan pi by 4 plus x. So this will be tan inverse tan pi by 4 plus x, मतलब pi by 4 plus x. So differentiation of this dy upon dx will be equal to 1. So this will be answer. Dy upon dx will be equal to 1. Similarly, we can do so many questions. If I put x equal to cos theta, if I put x equal to cos theta, question can be done because under root of 1 plus cos theta will be equal to 2 cos square theta by 2. So if I put x equal to cos theta, so whole question will change to y equal to tan inverse cos theta by 2 plus sin theta by 2 upon 1 plus cos theta by 2 minus sin theta by 2. If I divide numerator and denominator by cos theta, it will be 1 plus tan theta by 2 upon 1 minus tan theta by 2. That will give you tan pi by 4 plus theta by 2. So y will be equal to pi by 4 plus theta by 2. Theta by 2 can be written as half cos inverse x. Answer will be minus 1 upon 2 under root of 1 minus x square. This will be the answer. Now, let us see next. Similarly, you can do this question by putting x square equal to cos theta. You can do this question by putting x square equal to cos theta. So, half cos inverse x square आएगा, that will be equal to minus x upon under root of 1 minus x square will come. Minus x upon this will be the answer. Next question, write it minus x upon under root of 1 minus x raised to 4. Similarly, if I put x equal to sin theta, this will be tan inverse x upon under root of 1 minus x square. So this will be sin inverse sin theta will come and we can get the answer. What you have to do? Put x equal to sin theta. We shall get the answer. So what I told you, what you have to keep in mind, you have to either substitute or you apply the formula. For example, this is log x upon under root of 1 minus log x का whole square है. Under root of 1 minus log x का whole square है. So, if you write this log x upon under root of 1 minus log x का whole square है. You put log x equal to sin theta and you will get the answer. Put log x equal to sin theta. This is also very good question. So, next is cos inverse tan pi by 4 plus x by 2 cos inverse half cos inverse a by x plus tan of pi by 4 minus half cos inverse a by x half cos inverse a by x. Then f dash y is equal to tan of this one. Tan pi by 4 plus theta, if I put this as tan pi by 4 plus theta, this is tan pi by 4 minus theta. So this will be 1 plus tan theta upon 1 minus tan theta. So we shall get the answer. This is very good question. Pi by 4 plus theta, tan pi by 4 plus theta is equal to 1 plus tan theta upon 1 minus tan theta. Then second part will be equal to tan pi by 4 minus theta. So that will be 1 minus tan theta upon 1 plus tan theta. And if you do, this will convert to cos inverse. So this is the very good question. It has been asked in examination. Tell you the answer. So next is same question. Now next part. So we have done two things. First is how to use logarithm, and second, how to use substitution. And what you to keep in mind while doing the question of substitution is better to remember the formulas. Now in next part we do differentiation of the parametric functions. For example, what is telling you, if x equal to ft, x is function of t and x is ft, y is also function of t, y is gt, function of t. Then what he says, where t is parameter, then what he says, dy upon dx will be equal to dy upon dt upon dx upon dt, dy upon dt upon dx upon dt. The differentiation of the parametric function is very important as far as higher mathematics is concerned and in coordinate geometry also. For example, if I take x equal to 80 square, y equal to 280, this is parametric equation of the parabola. So this is parabola y square equal to 4ax, then its parametric equation is x equal to 80 square, y equal to 280. So if I differentiate it, what it says, dy upon dx will be equal to dy upon dt upon dx upon dt. So dy upon dx will be equal to dy upon dt, dy upon dt 2a upon dx upon dt 280. So answer will be 1 upon t. So this is the answer. Next question. X equal to a t plus sin t, y equal to a into 1 plus cos t. What will be dx upon dt? Dx upon dt, while dx upon dt equal to a into 1 plus cos t. Dy upon dt will be equal to a into minus sin t. So minus a sin t. Dy upon dx, a will cancel. So dy upon dt, due to sin t by 2 cos t by 2, this will be 2 cos square t by 2. This will be, answer will be minus 10 t by 2. Minus 10 t by 2. Sin t upon 1 plus cos t, if it is here not minus, that's why. Otherwise, it could have been the answer. So, in next part, we shall see, this is a very good question. X equal to a cos cube t, y equal to a sin cube t. This is the equation of the asteroid. And asteroid is very important. That's why differentiation of this function is very important. Dx upon dt will be equal to dy upon dx, dx upon dt minus 3a cos square t sin t. Dy upon dt will be equal to 3a sin square t cos t. Answer will be dy upon dt upon dx upon dt. So, 1 upon this, I have written wrong, dy upon dt, 3a sin square t cos t upon minus 3a cos square t sin t. Answer is minus 10t. Answer is minus 10t. You can remember this. Differentiation of x equal to a cos cube t, y equal to a sin cube t will be equal to minus 10t, because it shall be a very useful result. It shall be a very useful result for finding the other question. Next is x equal to a cos t plus log 10t by 2, y equal to a sin t. You differentiate this, dy upon dx, dy upon dt, a cos t, dx upon dt will be equal to a into minus sin t. Now, differentiation of log 10t by 2 will be equal to 1 upon 10t by 2. 10t by 2 का differentiation sec square t by 2, t का differentiation half आएगा. We shall get the differentiation of log 10t by 2, 1 upon 10t by 2, 1 upon 10t by 2, differentiation of 10t by 2, sec square t by 2, and differentiation of this will be half, so this will be a into minus sin t plus 1 upon sin t. So, dx upon dt, we are getting a cos square t, a cos square t upon sin t. Answer will be 10t. Answer will be 10t. Next is dy upon dt, a cos square t. So, answer will be 10t. Now, in next part, we do differentiation of the implicit functions. So, what is the meaning of the implicit function? First, we shall define this implicit function. If a function can be put in the form of y equal to fx or x equal to fy, then it is called simple function, explicit function. But if function cannot be put in the form of y equal to fx or x equal to fy, then this is called implicit function. So, what it says, for example, x cube plus y cube minus 3axy equal to 0. We cannot put this function in the form of y equal to fx or x equal to fy. These are called implicit functions. To do the questions of implicit function, you do differentiate it directly, and sometimes after simplification, we can do the questions. For example, if I differentiate it, then differentiation of x cube will be equal to 3x square. Differentiation of y cube will be equal to 3y square dy upon dx. So, 3x square plus 3y square dy upon dx minus 3a x dy by dx plus y. This is equal to 0. Now what you have to do? I can get cancelled dy 3, collect the terms of dy upon dx. So dy upon dx y square minus ax. Rest of the terms you keep in right hand side. So this will be y minus x square. Ay minus x square. So dy upon dx will be equal to ay minus x square upon y square minus ax square. This is x cube plus y cube minus 3axy equal to 0 is equation of the popular curve folium. That's why differentiation of this curve is important. So dy upon dx will be equal to ay minus x square upon y square minus ax. Now let's see. Y equal to x raised to x raised to x raised to x up to infinity is there. If I keep this term x as it is, so y will be equal to x raised to y. Take log of both sides. Log of y will be equal to y log of x. Differentiate it, dy upon dx into 1 upon y. This will be equal to y by x plus dy upon dx into log x. Take common dy upon dx, keep it one side and then find the result. Similarly, y equal to under root of x plus under root of x plus under root of x up to infinity is there. So this can be written as y equal to under root of x plus y. Now either you take log of both sides or you take the square of both sides. Y square will be equal to x plus y. Differentiate 2y dy by dx will be equal to minus dy upon dx will be equal to 1. So dy upon dx will be equal to 1 upon 2y minus 1. This is a good question because after simplification, that is after squaring both sides, question is hardly of one line. Most of the questions in a competitive exam where multiple choice questions are there, every question can be done within half minute or 1 minute. So what you have to keep in mind? You have to keep in mind that some sort of simplification is there. Some sort of simplification is there, or there is use of any standard result. This is very good question. X sin y a plus y upon sin y is there. If I put it x equal to a x equal to sin y upon sin of a plus y. This question has been asked so many times. If I find dx upon dy will be equal to sin a plus y cos y minus cos of a plus y sin y upon sin square a plus y. So dx upon dy sin a cos b minus cos a sin b, sin of a minus b is there. So this will be sin a upon sin square a plus y Sine A upon sine A square, A plus y, and if you reverse the result, then answer will be sine square A plus y upon sine A. This is important question. So whenever there appears x and y in such terms, first you find out dx upon dy and then convert it. This will give you result. Now the last part of the differentiation is differentiation of the one function with respect to other function. If you have to differentiate a function fx with respect to gx, then what you do? You put u equal to fx, v equal to gx, find du by dx, find dv upon dx, and then you find du upon dv. What I am telling you, if you are to differentiate fx with respect to gx, suppose u equal to fx, v equal to gx, then what you have to do? Du upon dv will be equal to u equal to fx, v equal to gx. Du upon dv will be equal to du upon dx upon dv upon dx. That will give the answer. For example, you have to differentiate e raised to sine inverse x with respect to sine inverse x. If I put u equal to e raised to sine inverse x, u equal to e raised to sine inverse x, v equal to sine inverse x, du upon dv will be equal to du upon dx e raised to sine inverse x upon under root of 1 minus x square. This is dv upon dx will be equal to 1 upon under root of 1 minus x square. If you divide it, answer will be e raised to sine inverse x. All the questions of differentiation of one function with respect to other function have been included in previous things, that is use of logarithm, substitution. So these are the more and more question can be formed. For example, differentiation of sine inverse x, u equal to sine inverse x, v equal to under root of 1 minus x square. You find du upon dx, you find dv upon dx, and you get du upon dx upon dv upon dx.